Hey everybody, um, should may get some stuff done, and then we'll get started on chemistry lesson or chemistry lab session 5. It's kind of weird, but there was two session 4s, and I didn't know about it till today. So I don't know. Da-na-da-da-da. All right, about to get started. There we go. Voila. All right. Last time we ended around this section, I was just gonna kind of reread some of this section on measurements to get back to here. Or actually, was it all the way down here? Anyway, here we go. I guess this could be like a last time on self-learnt. Last time in chemistry lab session 4, or one of the session 4s. Alright, here we go. By the end of this section, you will be able to explain the process of measurement, identify the three basic parts of a quantity, describe the properties and units of length, mass, volume, density, temperature, and time, perform basic unit calculations and conversions in the metric and other systems. Measurements provide the macroscopic information that is the basis of most of the hypotheses, theories, and laws that describe the behavior of matter and energy in both the macroscopic and microscopic domains of chemistry. Every measurement provides three kinds of information: the size or magnitude of the measurement, a number, a standard of comparison for the measurement, a unit, and an indication of the uncertainty of the measurement. While the number and the unit are explicitly represented when a quantity is written, the uncertainty is an aspect of the measurement result that is more implicitly represented and will be discussed later. The number in the measurement can be represented in different ways, including decimal form and scientific notation. Um, I'll just do a quick over. Talks about scientific notation, um, and units, obviously. Units such as liters, pounds, and centimeters are standards of comparisons for measurements. And then it talks about the um, SI system, the International System of Units, from the French Le Système International Internationale de Unites. Okay, and here's base units of the SI system: length, mass, time, temperature, electric current, amount of substance, and luminous intensity. Um, Sometimes we use units that are fractions or multiples of a base unit. Ice cream is sold in quarts. Uh, yeah, I already read all this. Um, anyway, these are really small numbers. A femtosecond is 1 times 10 to the negative 15 of a second. That's short. Um, these are the small numbers. Um, these are common unit prefixes. We got micro, which is 10 to the negative 6. We got milli, which is 10 to the negative 3. And we have centi, which is, wait, yeah, negative 3, negative 2. Uh, deci is negative 1. Kilo is 3 in the positive. Mega is 6. Giga is 9. And tera is 12. Link to learning. Need a refresher or more practice with scientific notation? Visit this site to go over this stuff. Alright, SI base units. The initial units of the metric system, which eventually evolved into the SI system, were established in France during the French Revolution. Hey, let's look up when the French Revolution was. Let's do it. Years of the French Revolution. May 5th, 1789 to November 9th, 1799. So 10 years, a 10-year revolution. A brief history on the French Revolution. The French Revolution was a period of time in France, obviously, when the people overthrew the monarchy and took control of the government. The French Revolution lasted 10 years from that date to that date. It began on that date when revolutionaries stormed a prison called the Bastille. Ooh, let's look up the Bastille. The Bastille. The Bastille. Two L's. Images. I don't think that was 15 things you may not know about the Bastille. Hmm. Guess it was just a prison. Anyway, back to it. Wrong one. Alright, anyway. The original standards for the meter and the kilogram were adopted there in 1799, the last year of the revolution, and eventually by other countries. This section introduces 4 of the SI base units commonly used in chemistry. Other SI units will be introduced in subsequent chapters. Length. The standard unit of length in both the SI and original metric system is the meter. A meter was originally specified as 1/10,000,000th of the distance from the North Pole to the equator. Wow, 1/10,000,000th. It is now defined as the distance light in a vacuum travels in one that. How much is now defined as the distance light in a vacuum travels in. Dude, how do they measure that? Let's look that up. in a vacuum stands at exactly 299,792,458 meters per second. Meters per second? The reason today we can put an exact figure on it is because the speed of light in a vacuum is a universal constant that has been measured with lasers. And when an experiment involves lasers, it's hard to argue with the results. Heavy videos? Visualizing video at the speed of light. 1 trillion frames. Alright, maybe not. Alright, a meter is about 3 inches longer than a yard. 1 meter is about 39.37 inches or 1.094 yards. Longer distances are often reported in kilometers. 1 kilometer equals 1,000 meters equals okay, that makes sense. You go 1, 2, 3. Alright. Whereas short distances can be reported in centimeters. 1 centimeter equals 0.01 meter or -2. 1, 2. Or millimeters. 1 millimeter equals 0.001 meter equals 10 to the -3 meters. Okay. Alright. So this is the length of a meter, yard, centimeter, inch. Okay. 1 inch equals 2.54 centimeters. The relative lengths of 1 meter, 1 yard, 1 centimeter, and 1 inch are shown, not actual size, as well as comparisons of 2.54 centimeters and 1 inch, and of 1 meter and 1.094 yards. Mass. The standard unit of mass. Let me take a break. We're going to see what's on Science Daily. Alright, so we have a 2,000-year-old remnant of a nova. Okay. Magma is the key to the moon's makeup. Here. Researchers have discovered the remains of a nova in a galactic globular cluster located near the center of the Messier 22. The finding, using modern instruments, confirms one of the oldest observations ever. Magma is the key to the moon's makeup. For more than a century, scientists have squabbled over how Earth's moon formed. Now researchers say they may have the answer. Deep learning takes Saturn by storm. A deep learning approach to detecting storms on Saturn shows the vast regions affected by storms and that dark clouds contain material swept up from something. A spinning black hole sprays plasma cloud. Astronomers have discovered rapidly swinging jets coming from a black hole almost 8,000 light years from Earth. The research shows jets from B404 Cygnes I want to pronounce that. Oh, pronounce Can I not just do it? Is there a Google pronounce? Like, Google. Oh, pronounce. Did it hear me talking? Alpha Sigma? Cygni. Okay. Thanks, sir. Alpha Cygni. Alright. Oh, sorry. Forgot what we were doing. Um, B404 Cygni's black hole behaving in a way never seen before. Okay. Latest top headlines. Magnets help AI approach efficiency of brain. Researchers have developed a process to use magnetics with brain-like networks to program and teach devices such as personal robots, self-driving cars, and drones to better generalize about stuff. Well, that's some scary stuff. The artificial intelligence could be a good thing, could be a pretty much a nuclear bomb. Engineers make injectable tissue a reality. A simple injection that can help regrow damaged tissue has long been the dream of physicians and patients alike. A new study moves that that dream closer to reality with a device that makes encapsulating cells much faster, cheaper, and that'll be good. Micro robot army wipes out dental plaque. Ooh. A swarm of micro robots directed by magnets can break apart and remove dental biofilm or plaque from a tooth. The innovation arose from a cross-disciplinary partnership among dentists, biologists, who else? Dentists, biologists, and uh, who would do that? I gotta find out. Engineers. Fuck, I should have done that. Synthetic speech from brain recordings. What? A state-of-the-art brain-machine interface created by neuroscientists can generate natural-sounding synthetic speech by using brain activity to control a virtual vocal tract. An anatomically detailed computer simulation includes the lips, jaw, tongue, and larynx. The study was conducted in something. Alright, top physical tech. Start with strange chemistry from out of town. Alright, let's go back to the reading. It's really slow going whenever I veer off the mission. Anyway, the standard unit of mass in the SI system is the kilogram. A kilogram was originally defined as the mass of a liter of water, a cube of water with an edge length of exactly 0.1 meter, or 10 to the negative 1 meter. Um, Maybe 0.1 meter, 1 to negative 2. Oh my gosh, I gotta look that up. Yeah, negative 1. Fuck. Can't believe I doubted that. Alright, gotta take a quick break. Real quick. I mean, I know I just took a break, but anyways. Something that has been going on the week personally. Um, my sister-in-law had a baby, and her and the baby are both fine. She's been in the hospital for months because she has a heart condition, and the baby was showing a heart condition, so they um, they were worried about what might happen, and so they wanted to monitor her, and anyway, they were worried about some vitals, like some vital signs or something. Anyway, so they ended up doing a C-section, which they were gonna do anyway. Um, and her and the baby are fine, so that's good. Um, on the music front, I hate to say it, but I've been really liking that Old Town Road song with the rapper and gosh, Billy Ray Cyrus. It's pretty good. All right. It is now defined by a certain cylinder of platinum iridium alloy, which is kept in France. Any object with the same mass as this cylinder is said to have a mass of 1 kilogram. 1 kilogram is about 2.2 pounds. The gram is exactly equal to 1/1000th of the mass of the kilogram. 10 to the negative 3 kilograms. Uh, if anybody listens to this ever, just drop down in the comments and just say like what's up or where you're listening from, or tell me to go fuck myself or whatever. Um, I'm just curious if anybody is actually listening, or if they're like, if you like listen to this for like 2 minutes and you're like, holy shit, I can't believe this dude's doing this. Anyway, just leave a comment, um, maybe with a suggestion. I know my voice is kind of monotone and southern, but I mean, I'm not gonna sit here and radio DJ this, be like, hello and welcome to Chemistry Lab Session 5. Anyway, um, let's go with temperature. Temperature is an intensive property. The SI unit of temperature is the Kelvin. The IU, that place, convention is to use Kelvin. The IUPAC convention, let's see what that is. IUPAC. 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 International Union of Pure and Applied Chemistry. Okay, now we know. Alright. Um, the IUPAC convention is to use Kelvin, all lowercase, for the word K for the unit symbol. And neither the word degree nor the degree symbol. I think I read that all weird. The IUPAC convention is to use Kelvin for the word, K for the unit symbol, and neither the word degree nor the degree symbol. Okay? The degree Celsius is also allowed in the SI system, with both the word degree and the degree symbol used for Celsius measurements. Celsius degrees are the same magnitude as those of Kelvin, but the two scales place their zeros in different places. But the two scales place their zeros in different places. The two scales place their zeros in different places. Water freezes at 273.15 Kelvin, or 0 degrees Celsius, and boils at 373.15 Kelvin. So it freezes. Oh no, that's 100. That's 500 more. Uh, and boils at 373.15 Kelvin, or 100 degrees Celsius. By definition, and human body temperature is approximately 310 Kelvin, or 37 degrees Celsius. The conversion between these two units and the Fahrenheit scale will be discussed later in this chapter. Alright, so probably just get through page 43 and call it a night. Time. The SI base unit of time is a second. Small and large time intervals can be expressed with appropriate prefixes, for example, 3 microseconds, 5 megaseconds, or 5 million, or, never mind. Alternatively, hours, days, and years can be used. Derived SI units. We can derive many units from the 7 SI base units. For example, we can use the base unit of length to define a unit of volume, and the base units of mass and length to define a unit of density. Volume. Volume is the measurement of the amount of space occupied by an object. The standard SI unit of volume is defined by the base unit of length. The standard volume is a cubic meter. A cube with an edge length of exactly 1 meter. To dispense a cubic meter of water, we could build a cubic box with edge lengths of exactly 1 meter. This box would hold a cubic meter of water or any other substance. A more commonly used unit of volume is derived from the decimeter, 0.1 meter or 10 centimeters, which would be about 25 inches. 1 inch equals, no. Okay. A cube with edge length of exactly 1 decimeter contains a volume of 1 cubic decimeter, dm3. A liter is the more common name for the cubic decimeter. 1 liter is about 1.06 quarts. A cubic centimeter, cm3, is the volume of a cube with the edge length of exactly 1 centimeter. The abbreviation cc for cubic centimeters is often used by health professionals. A cubic centimeter is also called a milliliter and is 1/1000th of a liter. Okay. So we have a one cubic meter, and one block of that is 1 decimeter, right? 1 cubic decimeter. That equals 1 liter. 1 cubic meter, that's 1 meter, right? It's cubic centimeter, okay. Cubic centimeter equals 1 milliliter. 1 cubic centimeter equals 1 milliliter, 1.8 centimeter done. Alright. Alright, looks like we're going to get into density next. Example. Alright, so we're going to get into density. I'm not sure how I'm going to... I know that at some point there's going to be math involved. I'm not quite sure how to mix that with the live stream. Um, anyway, I'll think about it and see if I can't figure something out. But let's finish on Science Daily. We're going to look at tech and go to chemistry. Alright, so chemistry news. Scientists 3D print all liquid lab on a chip. All liquid lab on a chip. What does that mean? Cleaner, cheaper ammonia. Artificial mother of pearl created using bacteria. Engineers demonstrate bubbles of sand. Latest headlines. Nanomaterials mimicking natural enzymes. A research team doped nitrogen and boron into graphene to selectively increase peroxidase-like activity and succeed in synthesizing a strategy to make graphene luminescent. A research project is able to incorporate luminescence into this supermaterial, paving a new way to continue expanding. Strategy to make graphene luminescent. Would that mean like free lights? Water creates traps in organic electronics. Partitioning of porous materials. New charge transfer and separation process. Scientists have discovered a new charge transfer and separation process named Twisted Intramolecular Charge Shuttle, or TICS, paving a new avenue for chemists to construct unique and useful fluorescent stuff. Thin film solar cells. A team has succeeded in producing inorganic perovskite thin films at moderate temperatures using co-evaporation, making post-tempering at high temperatures unnecessary. Simple color tuning of LED bulbs. Squid skin and next-gen space blanket. Drawing design inspiration from the skin of stealthy sea creatures, engineers have developed a next-generation adaptive space blanket that gives users the ability to control. I gotta read about that one. I also want to read the graphene one. Let's go. Adaptive space blanket that gives users the ability to control their temperature. The innovation is detailed in a study published today in Nature Communications. Alright, I think I can read that really quick. Alright. Ultra lightweight space blankets have been around for decades. You see marathon runners wrapping themselves in them to prevent the loss of body heat after a race. But the key drawback is that the material is static, said co-author, that guy that works at that place doing that thing. We made a version with changeable properties so you can regulate how much heat is trapped or released. Let's get down to here. Clothing would be a particularly fitting application for the new bio-inspired material, according to that guy. Gorodetsky, who collaborates on research projects and counterparts at athletic apparel manufacturer Under Armour Inc. The temperature at which people are comfortable in an office is slightly different for everyone. Where one person might be fine at 70 degrees, the person at the next desk over might prefer 75 degrees. He said, our invention could lead to clothing that adjusts to suit the comfort of each person indoors. This could result in potential savings of 30 to 40% on heating and air conditioning energy use. I bet you electric company don't want to hear about that. And those marathon runners who wrap themselves in space blankets might be able to type in a number on a garment integrated user interface to achieve the desired level of thermal comfort, optimizing performance during races and recovery afterward. Other benefits that guy mentioned include the material's lightweight, ease and low cost of manufacturing, and durability. She noted that it can be stretched and returned to its original state thousands of times. this world is getting weird. Or awesome weird. Alright, we'll end on this. Lighter than aluminum, harder than a diamond. Lighter than aluminum, harder than a diamond. More elastic than rubber and tougher than steel. These are only a few of the characteristics of graphene, a super material that acts as an excellent heat and electrical conductor. Due to its features, it is called upon to be a key player in future technological advances in the fields of research, electronics, IT, and medicine. The FQM-346 Organic Chemistry Research Group at that place came up with the way this material acts in a luminescent way. A new feature it did not have before, and that now ushers in a new range of applications. Professor that guy, one of the authors of the research piece, explains that luminescence is a characteristic of some substances which allows them to emit light at a different wavelength than the one they absorbed it at. In other words, luminescent materials can emit visible light from energy, a property that makes them useful as photocatalysts and fluorescent tags that can be displayed in macromolecules and biological materials. Now, thanks to this new research, luminescence is added to the long list of services graphene can provide. This research was published in Chemistry, a European journal sponsored by that place, and also involved the work of that guy or those people along with that group. Because of its degree of relevance, this journal describes the article as a hot paper. Though previous attempts have been made to endow this supermaterial with light properties, all of those were unsuccessful. What really makes graphene special is its hexagonal structure based on highly cohesive carbon atoms by means of a kind of electronic cloud in the shape of a sandwich. If the connection between the atoms in this cloud is interrupted, part of the properties are lost, explains researcher Francisco Romero. Specifically, overcoming this obstacle is where the success of the research lies. The group was able to incorporate luminescence into this material without affecting its other qualities, thus safeguarding the functionality of its complex structure. In order to do so, europium was integrated into graphene. Europium is a metal that perfectly coordinates with the modified molecules of the supermaterial and is the one that grants it its luminous properties. The results offer immediate applications. Since this luminescent graphene could be used in biological material and for analyzing tissue cells, however, the research goes even further. The use of europium is just a concept test, explains that dude from that place. Henceforth, this study opens the door to the use of a variety of chemical elements that could be combined with graphene to confer new characteristics on it. For instance, if certain kinds of metals are integrated, a magnetic graphene could be generated. Ultimately, it is a line of research that this group, which belongs to that university and that college, will continue to work on with the aim of adding new properties to the list of graphene's qualities. Doing so will increase the versatility of this substance that holds very promising characteristics and that has already earned the right to be called a material of the future. Anyway, alright guys, I will see you later.